Today we're going to be taking a look at the test selections for the game of tennis, and more specifically, collegiate level tennis. Let's start with continuing my needs analysis. Tennis is a high-intensity multiplanar sport that demands a lot from its athletes, and so my strength and exercise program, as well as my warm-up, would look to target explosive power and strength in transverse and sagittal plane movements. Training should also look to increase anaerobic and aerobic capacity, as that is vital to optimal performance and safety for athletes. Training should also look to decrease injury risk by focusing on the joints of the knee, the elbow, the shoulder, and the hip, as well as the surrounding musculature around said joints. These joints are chosen for a reason, and that is because they are the joints that are most prone to injury while the game of tennis is being played. Some of the exercises I would use to target those injury-prone sites would be power and strength exercises in push and pull movements, explosive lower body movements, trunk stability, and some agility and reaction time exercises as well. The first test that I would conduct with my athletes would be anthropometrics. And anthropometrics are vital because they provide a quantitative and comparative baseline for you to compare an athlete's progress over the course of a season. If you take the measurements at the beginning of the season and at the end, you can measure things like weight, body mass index, body fat percentage, etc., to see how they have improved towards a set goal over the course of the season. And for example, if you want to look at the ACSM body fat percentage category for men based upon age, this is one of the metrics that would be used to compare the body fat percentage anthropometric data to the normative values listed here. And if an athlete is outside of these healthy values, then that can be utilized to prescribe some programming, whether that be to lose body fat or increase muscle mass or something of that nature. Range of motion assessments are my next test, and we're focusing specifically here on the shoulder mobility FMS test and the inline lunge FMS test. The shoulder mobility FMS test examines the internal and external rotation capabilities of the shoulder, which is vital for the game of tennis. The shoulder is one of the most injury-prone sites on the body while playing tennis, and so being able to be assessed and scored to see if an athlete is lacking in shoulder mobility is critical to optimal performance and safety of the athlete. The inline lunge FMS test examines hip and ankle, knee, and quadricep flexibility as well as stability, and this really targets the demands of the lower body that tennis asks for. And just like the shoulder FMS test, if an athlete was found to be lacking in this area, some exercises like lunges, squat, or dorsiflexion movements could be prescribed, and as well as some banded pull apart or lateral frontal raises for the shoulder mobility or lack thereof. The next test would be the star agility test, and this is a test that really looks to examine the acceleration, deceleration, and change in movement direction of athletes. And this is vital for tennis players because tennis players run forward towards the net, they run backwards, they run laterally, they run diagonally, they run all over the court. And so a test that assesses all of this and gives you some normative data to compare it against is paramount to assess the strengths and weaknesses of your athletes. For example, players perform approximately 1.5 to 2.5 directional changes per rally, which is almost 100 directional changes per set. And so with this agility test, if an athlete was found to be lacking, then some prescribed agility or explosive power movements, and as well as some biomechanical work to make an athlete stop and start correctly and safely would be prescribed and would help to benefit them in the long run. Max vertical jump is the next test, and this is a max power assessment that is looking at the vertical explosive power of the lower body. And like all the other tests, this gives a metric for coaches to base training on. And the max vertical jump is an important test as it applies to tennis because serve speed and improved serve biomechanics are directly linked to jump height. And so if an athlete is struggling to jump vertically, then their serve and their game overall is going to suffer as a result of that. And so if an athlete is suffering, then increased power and strength training during the offseason or preseason could be prescribed in order to get them to an optimal level. The 10-meter sprint is a sprint test that measures acceleration and speed in a very sport-specific context for tennis. And you might ask, why 10 meters and not 20 meters or 30 meters or something of that nature? But 10 meters is actually very specific to tennis as the courts are 36 feet wide, which is approximately 10 meters, and 78 feet long. And if you divide 78 feet by 2, because an athlete only covers half the court at a time, then that is roughly 10 meters as well. So the 10-meter sprint is a direct correlation to the distance that an athlete actually covers on the tennis court. And some of the normal values for collegiate tennis athletes would be to complete this 10-meter sprint in 1.5 to 2.5 seconds. So if an athlete didn't fall in between that category, then some explosive lower body training could be prescribed in order to get them to an optimal level. The last test I have is the shuttle run or the beep test, and this is assessing aerobic capacity. And aerobic capacity is so important in the game of tennis because while it can be seen as primarily an anaerobic sport, the aerobic side of things is utilized to increase recovery and decrease fatigue in between anaerobic bouts. And so with this increased aerobic recovery, you delay the fatigue between the anaerobic system activation and increase your performance during matches. And this increased performance helps athletes to maintain attention and concentration and overall perform at a higher level for longer. And overall, the test selection order that I chose is based on the literature that we covered in class, with the non-fatiguing tests being the anthropometric or range of motion assessments, followed by our agility test, which is the star drill, a max power test in the form of a max vertical jump, a sprint test in the form of a 10-meter sprint, the local muscular endurance test. I did not pick one of those, but that would be the next logical step. The fatigue and aerobic capacity, I also did not pick one of those, but the aerobic capacity test in the form of the shuttle run / the beep test was a test that I chose to include in my selection as well. And here are my references. Thank you so much.